Hello everyone, I am Dhanashri Bhandare from SYBCSE. Today I am going to explain NRU, not recently used page replacement algorithm. It is an approximation of a least recently used algorithm. This algorithm uses two important bits maintained by operating system for each page in a memory, the referenced, which is R bit, and the modified, which is M bit. These bits help classify pages into four categories based on their recent use and modification status. The classification is as follows. Class 0, R is equal to 0, M is equal to 0. The page has not been referenced or modified recently. Class 1, R is equal to 0, M is equal to 1. The page has not been referenced recently but has modified. Class 2, R is equal to 1, M is equal to 0. The page has been referenced recently but not modified. Class 3, R is equal to 1, M is equal to 1. The page has been both referenced and modified recently. When a page fault occurs, the NRU algorithm will always try to replace from the lowest numbered non-empty class, preferably class 0, as those are the least important to keep in memory. Example of NRU page replacement algorithm. This is the page reference string and the number of page frames are 4. For the simplicity, we will assume initially all pages have R is equal to 0, M is equal to 0. On the page axis, R is equal to 1 is set. We assume no modification, that is, M is equal to 0 unless explicitly stated. R bits are reset every 4 reference. Assumptions for NRU. Page frames are 4. Page reference string. R bits reset after every 4 reference. Initially, all R is equal to 0, M is equal to 0. M is equal to 0 always, no writes assumed. NRU replaces a page from the lowest number non-empty class. We have already seen the classes. This is the page reference string of NRU. Here, for the number 7, 0, 1 and 2, page fault occurs. Next, for number 3, a page fault occurs. For number 4, again it is a hit. And for the same, we will continue the process. Here is the step-by-step highlights. References 1 to 4, that is 7, 0, 1, 2, all new pages are 4 faults. After 4 reference, the R bit resets. Then reference by, which is 0 already in memory, just update R, that is no fault, which is a hit. Reference 6, which is number 3, need to replace. Pick from class 0, say 7. Insert 3, which is fault. Again, for the reference 7, which is 0, a hit occurred, which is no fault. For reference 8, number is 4, replace class 0 page, let's say 2. Now insert 4, which is a fault. After reference 8, reset R bits. For reference 9, the number is 2, which is not in a memory, so replace 3, which is a class 0, and thus it is a fault. For reference 10, which is number 3, and it's not in a memory, so replace 0 with the class 0 and it occurs fault. For reference 11, the number is 0, which is also not in memory, so replace 1. It is a class 0 and hence occur fault. After reference 11, reset R bit. Now reference 12 to 14, that is 3, 2, 3, all are hits, which means no faults. So the total page faults are 9. Here is the more detailed explanation about the problem.